So in my last video, I talked about partial fraction decomposition, and in the end, I mentioned why it was useful when we were studying calculus with integrals and derivatives. So remember that if we had 5x plus 3 and we were dividing it by x squared plus 6x minus 7, I talked about at the end, it would be impossible to integrate something like this right away. Right away. So if we want to take the integral, let's say with respect to x of this integral, right, how could we do that? Well, with partial fraction decomposition, we know this integrand, right, this rational expression, that was the same as 4 over x plus 7, and then we had plus 1 over, over x minus 1. So when we made x minus 7 and x minus 1 are common denominator when they were multiplying together, and we kind of expanded this out and got it back into this original form, it would be the exact same thing. All we did was we took it in its original form and broke it up into two fractions that we're adding together. So taking the integral of this original thing would be super difficult to even kind of conceptualize, because we can't use u substitution or anything like that. But if we break it up like we did here, that's just the integral of this first term plus the integral of this second term. So now what we did is now we have two integrals that we're taking the antiderivative of with respect to x that are relatively easy to compute. So the integral, I'll call it I, okay, of the integral of 4 over x plus 7 dx, that's the same as 4 times the integral of 1 over x plus 7, right? Because the 4 really just multiplies into the 1 there, and then we're adding the integral. That 1 is already there, so there's no coefficient on the outside, plus the integral of 1 over x minus 1 dx. So what we have now is two integrals adding together. Not too difficult, right? Because we have the integral of 1 over x plus 7. Remember, the integral of 1 over any linear term is just so we have 4 here, times, it's going to be the natural log of the absolute value of whatever that denominator is. So in this case, it's x plus 7. And for the second one, 1 over x minus 1, taking the antiderivative of that, we get plus the natural log of the absolute value of x minus 1. Okay, so since x plus 7 and x minus 1 are our denominators, right, those are both linear. On the top, we have a constant that we factored out. And so we had 1 over that linear term. The antiderivative is just the natural log of x plus 7, and then the natural log of x minus 1. And the reason for that is, if we had, let's say, we had the integral of 1 over, another one might be like x minus 4 dx, right? We know that the integral, and I proved this in another video, the integral of 1 over x is equal to, I need the dx there, 1 over x dx, so that is equal to the natural log of the absolute value of x. Right? Well, if there's anything other than x here, like an x plus 1, right, this would be the natural log of x times d by dx. Actually, I'll write it as like kind of a formula. I'm kind of getting sidetracked, but I'm just explaining because the natural log comes up a lot in these questions. If we have the integral of 1 over x plus a, say, where a is a constant dx, this is equal to the natural log of the absolute value of x plus a times d by dx of x plus a. Well, you notice that the ln of x plus a is the same. And then times the derivative of x plus a, that's just the derivative of x plus the derivative of a. Well, the derivative of x is 1, and the derivative of a is 0. So this is times 1 plus 0. And we're just multiplying it by 1, so we just get the original thing back. So if your denominator is linear, like x minus 4 and what were they? X plus 7, x minus 1 all are, right? It's just the natural log of that denominator. So this is how you can use partial fraction decomposition to integrate functions that are that have rational expressions in the integrand. And yeah, you can kind of break it up into two things that are adding or subtracting. Then the integral becomes a lot easier, and you just add or subtract those integrals from one another to get your answer. Okay, and I kind of went on a side note talking about the natural logarithm, but it's necessary because I guarantee like the majority of these questions, the answers are primarily composed of the natural log, and always we need our plus c, right? I kind of forgot it there, but when we take the indefinite integral of a, and I forgot my dx here as well, holy, forgot a couple things, getting sloppy. Dx plus integral there, we got our plus c, and yeah, hope this was helpful, and I'll see you in my next video.